Hello, and welcome to another episode of Out of Thinaer. My name is Beverly Lwenya, and this is the podcast where IoT meets innovation with expert insights, real world use cases, and smart business strategies. Today, I'm joined by a very special guest. I had the pleasure of meeting her over lunch at a recent conference, and I knew right away she'd be a fantastic guest on the show. Please welcome Karina Corkum, Manager of Digital Manufacturing Strategy at Northrop Grumman. Welcome, Karina.
Thank you so much for having me, Beverly. I'm really pleased to be here.
Yeah, I'm glad that you're here too. And we accidentally matched today, so this should be a good sign that we're going to have a great conversation.
I think so. I'm looking forward to it.
Great. Well, let's get started. Maybe you can start by way of introduction. Tell us what you do at Northrop and a little bit about your journey and how you became so passionate about digital transformation.
At Northrop Grumman, I focus on digital manufacturing strategy at the corporate office, and I came via the circuitous route. I started my career in what I call the original digital transformation project, which was Y2K, for an advertising conglomerate. And I'll tell you that the digital transformation journey hasn't changed too much since then. And after I did that, I did a little bit of management consulting. And, when I first came out of school, I really thought, I have so much to learn. There are so many things that I don't know. And when I came into the workforce, everybody just worked on spreadsheets and Word documents. And I'm not sure that much has changed since then. During my time as a management consultant, 9/11 happened, and that was a very tumultuous time because mainly I was working down in the financial district in New York City, and the world, or at least the city and the tri-state area, pretty much stood still. I would say it's kind of like the pause that happened during the COVID lockdowns. Everything just kind of stopped. And it was a good time for me to transition and take a pause out of New York. And we ended up moving to Maine. And I transitioned into fintech and worked for a company called WEX. And they manage fleet payments. So it's a data company, right? They really focused on ways that big trucking companies would use their fuel purchases. And there was a whole suite of analytics on that. And that's really where I learned about automation and testing and automating testing and all of that. And that was a really good time, but I was ready to move on from Maine. And that's how I got into the aerospace and defense industry. I got a call and a contract at General Dynamics Land Systems because I had worked with a particular software at WEX and took a leap and moved to Michigan and supported General Dynamics in the system engineering department, doing requirements management support with this application. And that's where I really honed my software engineering skills. And my degree is in computer science. And so software engineering has been a big part of my life in automation. And that's really where I truly understood how software and data augment the business, right? Especially within a system engineering department. And after that contract was over, I moved into orbital sciences, which was later merged with ATK, so it became Orbital ATK, and then finally was acquired by Northrop Grumman about 7 years ago. And at Northrop Grumman, still in the system engineering department, I stood up an organization that was focused on innovation and maturing capabilities like model-based system engineering, multidisciplinary analysis and optimization, still requirements management, and other things, right, that were concerned on the engineering side with digital thread. And we were developing capabilities and best practices. This was kind of before formal digital transformation efforts. We were kind of doing digital transformation from within the department and reaching out wider across the company. And I really wanted a bigger impact. And so about 4 years ago, I switched to the corporate side at Northrop Grumman, and the job was innovation, but with a focus on manufacturing. And I had never really had a manufacturing focus before. And in fact, by being a software engineer, I feel like anything is possible with software because you don't have to rely on the laws of gravity, if you will. But in manufacturing, there are just some different rules. But, when I went down the rabbit hole of manufacturing and just realizing all of the opportunities to help the company on a larger scale, I was hooked and I've never looked back.
Wow, that's such an interesting background. I'm young enough, I guess, to remember the Y2K days and just the panic that set in. And it's so interesting because that really is the original digital transformation
Yeah,
plus preparedness case study, right? And just
right,
how everyone was like, the world is going to end, and do we have a strategy for
right.
what happens when Y2K hits? And we made it.
And it was fine. Yeah.
Yeah, it was largely fine. But I think it got a lot of people thinking as to what do you do when you need a plan or a strategy to transition your systems, your people, your culture, not only into a new decade and century, but um, yeah, just technology. So interesting. And also, you have a pretty technical background as a software engineer. So, what excites you about the smart factory and the concept of a smart factory, especially in aerospace and defense, right? What is exciting about that, and what's interesting?
Yeah, so many things. When I think about digital transformation in aerospace and defense, I think of it in a couple of ways. One of them is really being data driven and enabling the factory to have access to data, but it's also unlocking capabilities that maybe weren't available in the factory before, right? Being able to do predictive maintenance, which is also based on data, but just capabilities that just really have to be manually managed to be part of an ecosystem. I think that's what is the most exciting thing for me. And I think that Northrop Grumman continues to innovate in that area. There was a recent article that came out that featured some of the digital thread capabilities with one of the vehicles that we produce, and it really has changed the game in being able to analyze data and make those decisions before being in physical space.
Definitely. And so, from your experience at Northrop Grumman, what are some key factors that have driven successful digital transformation in manufacturing that you've seen?
I think that's something that is important in innovation is really solving the immediate problems that a factory encounters and then iterating upon those problems. I think a lot of times, we want to solve the entire problem and provide everything all at once. But I think that from a change management perspective, from a financial perspective, from just even the appetite to be able to change that quickly, I think that it's best to solve the problem and then continue to build upon the solutions. That has been really one of the key ways that we've been able to see change stick.
So you previously mentioned before spreadsheets and, sort of this clipboard, pen and paper, more analog way of data collection. What are some projects that you might be able to highlight, advanced IoT analytics that have been implemented that improved efficiency for manufacturing?
One of our big initiatives is focusing on converging IT and OT and being able to move data effectively from the shop floor into our Northrop Grumman network so that we can do analytics, and we've had several successful ways that we've done that. I'm limited in what I can say, but what I can say is that we have been able to see some advances in the kind of data that we're able to collect and being able to analyze that data in aggregate and make some pretty interesting decisions. I think that a lot of times, depending on what problem you're trying to solve, right? I'm in the IT space, and so I'm looking at this from a corporate level, but each of the factories have their own view of what the data looks like, right? And so for them, it showed what was actually happening within their space. For me, it showed that we can deploy something to a remote factory and then replicate it. And so there's just so many different perspectives when you talk about digital transformation or any kind of smart factory, depending on who you talk to, right? Depending on their perspective, they have a different view of it. I also believe that as we continue on our journey, the factory really becomes the product because it can unlock so much for the programs that we support and the customers that we support. So that's how I'm approaching it. And I'm excited to continue to innovate. I'll say that.
Interesting. You said that the factory becomes the product. Can you say a little bit more about that?
Yeah, I think that the more we can understand what's happening on the shop floor, because we have systems in place to analyze data and to understand what's kind of happening at all of our factories, the more we can understand what kind of manufacturing is happening at those factories, right? We don't build a product, right, and then sell that product. We are contracted by our customers, right, Department of Defense or NASA or whomever, to build bespoke products, right, whether they're airplanes or rockets or satellites or radars, whatever they happen to be. And sometimes it's just software, sometimes it's something else. But those are the types of things that we're really trying to optimize, right? How do we consistently deliver those products, recognizing that each of those products is going to be different and needs to be custom, right? We can't, just stamp something out. It's something that has to be customized. So in that way, right, the place where we manufacture needs to be optimized to customize. I'll say it that way.
Yeah, no, definitely. Understood. And so you mentioned your customers, the defense industry, aerospace. It's also a really exciting time in aerospace right now. Um, how do you balance innovation with critical regulatory and security needs, especially in these sectors?
It's incredibly challenging to innovate in this type of an environment because, like you said, we have a lot of regulatory and cybersecurity requirements that really you cannot waive because of how critical cybersecurity is to the defense of the products that we make and to the factories that build those products. We have several test environments that allow us to innovate. And a lot of times, I'll, in the best possible way, we go rogue sometimes, right? And we identify problems that we can solve. We identify use cases that maybe affect multiple factories, or maybe even just one factory, and we solve that problem in a virtual environment, and then we demonstrate it. So kind of like the concept of the Prove It conference where we met, right? We prove that we can solve the problem, and this is something that I've been doing pretty much throughout my entire career. There's always a detractor somewhere that will say, no, you can't use this software. No, you can't do it this way. You need to do it this way. And in my mind, as long as the problem is solved, as long as we meet the intent of doing what is necessary, does it really matter how we get to it? I think that we will not compromise on the regulatory requirements or the cybersecurity requirements, but that's not going to stop us from solving the problem in the best possible way and then overlaying those requirements on top of the solution. Sometimes that can be challenging because not everybody sees the vision all the time. So you kind of have to solve it and then bring it to everybody and make these presentations and then bring everybody in. That's one of the ways.
Yeah, and I'm sure it can be challenging. That's my next question, actually, getting everyone to see the vision. So what role does systems engineering play, especially when you have a lot of times this IT and OT divide, or, maybe just different needs that they have and requirements? How do you successfully bring a team, a culture together, especially in large organizations?
Yeah, that's a really good question. And it's a very important topic and one that's very close to my heart. As the physical becomes digital, right, as we move into kind of simulating our manufacturing environments and trying to understand the data that we have, we need to bring system and software engineering to manufacturing. We need to be able to utilize the best practices that have been working in the software engineering realms for decades. And we need to bring that to manufacturing. And a really great way to do that, that we've found, has been through model based system engineering. It's something that allows us to create a standard and consistent way to bring engineering rigor to the way that we address technical problems and the way that we capture data about our factories so that we can accurately do trade studies for software vendors or for technical solutions, or just to even understand and build our solution architecture, right? So not only network architecture, but overall solution architecture. And it also allows us to connect our manufacturing to engineering in a very real way. And it's not something that is monolithic, right? I think that everybody in their own domain area can utilize system engineering practices to innovate and to capture data about their solutions, and then connect it all together and understand what the full scope of the problem is, right? Depending on the problem that you want to solve. So we do successfully utilize system engineering practices to innovate and to really pull in the technical data and solutions.
Have you faced any challenges with implementing that model? And if so, what are some common, you know, what's some common pushback that you might receive?
There's always pushback when people don't understand it. I think that when you utilize model-based system engineering, it kind of changes the way that you plan and define work and what that work looks like. And so it doesn't necessarily look value added to people, right? They want a product, like I want a playbook or whatever that might be. And so they're saying, I need this document to give me information. And they expect that. And we're working in a model to define and to collect and to analyze. And at the end of that activity, because we're applying very specified practices, we can generate an output that will have similar information. Will it look the same? No, it'll be a little bit different. Could it be a document? Yes, it could be a document. Is it going to be as verbose? Not necessarily, but I think that people feel like you're spending too much time not writing a document when all they want is a document. And so I think that there's just not necessarily an understanding of what those activities are and how they're valuable. And as we collect more data within our model, we have 65 plus factories within the United States at Northrop Grumman, and a lot of data get collected in spreadsheets. And we don't get a full picture unless we're able to really pull it into something that has real software or a graph database behind it to be able to understand and answer the questions that we need to answer, right? Like, what MESs are in use at these factories and what are those archetypes? And yes, you can use Excel for that, but it doesn't necessarily connect it to the overall architecture of the factory. It doesn't necessarily connect it to how we're solutioning within those factories. So it's been an interesting experience, bringing model-based system engineering to the manufacturing domain. And I think that the more people see what's possible and see that they can really get the answers to the questions that they're asking, the more they're starting to even ask for, hey, can you see what we can get out of the model for this question?
Yeah, something I remember from the conference as well is Walker talked about who was the host. He talked about I guess it was a debate on whether you can go it alone or whether integration partners are needed. And so for you all at Northrop, how do you go about working with partners? You have 65 factories, that's a lot. What role do external partners play in that?
We do have a very complex space, and many factories do use system integrator partners and vendor partners, and we rely on contract labor to provide different solutions. But because my team is at the corporate level, we try to stay involved in some of those activities and capture as much of those activities in our model as possible so that we can kind of integrate all of that at the enterprise level. I think that we need to rely on our partners. I think that there are so many best practices, right, that need to be employed. I think that it's challenging for one team to service 65 factories, and so you need to really reach out and augment the knowledge and just the art of the possible that exists out there.
So switching gears to the future, and buzzwords like AI, what emerging technologies are you most excited about? And are you seeing in the horizon that might impact your work and the industry at large?
AI continues to be the word of the year in 2025. I think that just the efficiencies that we've seen, right? Just even with Chat GPT, right? Or even meeting transcribers, right? Or just even on your iPhone when you get a voicemail and you can get that in textual form, that is a game changer. Or just even doing a voice note and having that transcribed has been a game changer in efficiency. And I am really excited about creating an infrastructure and an architecture that can support the future innovation. And I think that's really the most important piece. Can you design an architecture within your corporation, within the ecosystem of the way that you do business that can be future proof, that can really enable you to modularly move things around as we see technology advancements? I think that's incredibly important. And I think that software architecture, network architecture is really underrated because it is going to be what enables us to be nimble.
Totally. I think you bring up a good point about how AI has impacted us on the individual level. So with ChatGPT or, your iPhone and voice memos. But there's sort of a race to see the impact on the enterprise level and for business outcomes. Because those are much bigger levers to pull, how to integrate AI and automation, especially on that level. So interesting. And so what would be your advice for someone who's just starting out, a manufacturing manager, a floor manager, or an operations director, even a CEO, someone just starting out with the concept of factory of the future, and they want to talk to their team or someone higher up about digital transformation. What are some best practices that you would give them?
I'd say the most important things are to solve the problems that are immediately in front of you, but also understand that those are only the problems that are immediately in front of you. You cannot, and I can't say this enough, I cannot overstate the fact that the architecture that you have in your factory for data movement, for analysis, for just even setting things up in an efficient way, it really can't overstate that, because things change so quickly, and the problems that maybe you're facing today are not going to be the problems that you face tomorrow. So you need to be nimble enough to deal with that. And if you focus on the right architecture, you can solve any problem in front of you.
Final question. Any recommendations you'd like to leave our audience, especially those within the defense and aerospace sector? Any final thoughts?
I would ask people within the aerospace and defense space to ask themselves, what problem are you trying to solve? I think that when we think about digital transformation, there's so many different aspects to it, right? My view of what efficiency looks like from an IT space is very different than what it looks like from manufacturing space, and very different than what it looks like on the engineering side, or just even supporting programs that are building these rockets or satellites. They're solving problems that are around the vehicle architecture and being able to manufacture those vehicles. On the IT side, we may be solving problems that are around cost efficiency or software licensing or being able to deploy something to all of our 65 factories, whereas the factories are really looking at themselves and finding efficiency with themselves. And all of those things are important in a company. And when I think about, right, how do you know digital transformation is successful, right? It depends on who you ask, and it depends on what problems you're trying to solve. And the measure of my efficiency, right, to be able to provide cost savings to 65 factories or to be able to deploy something is a different measure of success than being able to manufacture something. So I think all of those viewpoints are valid and necessary. But I think that when we think about digital transformation, we kind of think about what it means for us, and maybe we miss some of those other viewpoints. So I would advise them to think about all of the different ways that we could measure success.
And that's a great note to end on. Thank you so much, Karina, for taking time out to speak to us about your expertise and your knowledge. Clearly, just a really interesting background. And we wish you the best of luck. And for those of you watching, thank you for tuning in to another episode of Out of Thin Air. Please join us again soon and be sure to subscribe for more episodes. Thank you. See you next time.